Okay, let me see if I can show you this here in the video. We faced the part like we did in the first part of the program, and we drilled halfway through the part. And kind of the reasoning behind this, if I can demonstrate this, let's see if I can show it to you. You can see it. See, the part's up against that jaw pretty good. See the gap? You can see that between that jaw, because in order to get the part to stick out straight from the chuck, it's not too bad on that jaw. It's up there pretty tight on that one. So it's kind of got a gap on a couple of these jaws, I think, or maybe just that one. Now see that one, so those two jaws have a gap there, and I don't want to do this heavy roughing and be pushing back against the part, or and have it shift in the jaws for some reason. This video is going to be about the CAD and the cam of this part on the monitor behind me here. And the clip you just saw in the video is, well, I put it in there in purpose of the machining part of it, the beginning of the machine work, so that you could kind of understand what I'm talking about in part of this video. That's the reason it's there. And like I said in the previous video that I posted on the battery issue with the Mazak, that these kind of videos might not be for everybody, but I've had people in the comments ask me to make this kind of a video, so that's the primary reason I'm making it. I think it's important to show kind of the process of going through the CAD and the CAM part of planning a job, if you will, and programming it. So that's what this is going to be about. And I'd like to make a couple of comments about previous comments on the parts like this, because people have commented, or maybe they don't watch the whole video, I don't know, but they say that, oh, why didn't you start with a smaller piece of material? Well, you can't use a smaller piece of material diameter-wise, because there's this flange on the end of the part, and if you want it out of one solid piece, you have to machine it out of a bar big enough to get that flange diameter. So that's the issue with that. I don't know, maybe they don't understand that when they watch the video, or they didn't watch the whole video and they just type in a comment and click away. I don't know. And also, people talked about tree panning tools, and yes, a tree panning tool can be, that can function and be made to work, but not on my machine. There's no way I can mount it. I don't have the tooling. I can't mount it in the machine, and it would be just as expensive to make the tooling, the tree panning tool in the first place, for the few parts that I'm making here. So that really, that doesn't really work out for me. I mean, it's not impossible to do. You're not incorrect when you say that, but it just isn't my setup. And also, the material you're wasting, this 4140 costs about $1.40 something a pound, and you are wasting material here, but sometimes it's easier to waste, or it's quicker. In this case, there was a time issue as well. I've got to machine these parts in a certain period of time, and there's no time to go out for, or to make special tooling, or to go out for forgings to get closer to the net shape, or even to have two parts welded together. And the economics of this, I don't think people quite understand that part of it. Even if I was to weld two pieces of 4140, I have to get a flame cut disc, and then I have to take a bar that's big enough to get the shaft part. I'd have to prepare them before I send them to a welder, because it has to be a certified welder to do it, because you have to show certifications on stuff like this, and he has to weld it, and he's going to charge me to weld it, and it's going to cost as much as the material I waste. And on top of that, the customer had a failure with a part made like that, so they don't want to do it that way again. They just want to go out of solid, be done with it, not worry about welding problems or anything. So those are the reasons that this part is being machined out of a solid bar. And I know there's other ways to do it, and possibly be more economical if you were making, hundreds of these parts, but we're only making a few of them. And this is the most expeditious and economical way, I guess you'd say, to do this job. So I just want to make those things kind of clear those up, because I got numerous comments on the previous video that I made on a shaft similar to this. Got almost 1 million views, and you wouldn't believe the number of comments that people make and repeat, because they don't read the comments, I guess. And I could appreciate that if you got 500 comments on a video, nobody's going to read through all of them. But I just want to say that because I know that people that watch this video and the video on machining this part will make those comments as well. And maybe if they watch what I'm saying in the first part of this video, they'll understand why this part is being machined out of such a big solid piece of material. This is just the way the customer wants it, and it actually is the most economical way to do it for the period of time that's given to do the job, if that makes any sense. So let's watch the video and see how I do the CAD and the CAM part of this setup. All right, I thought I'd show what I do when I first get a job and the things I do to start the programming, because you got to do a few things in the CAD software. Now this is my CAD software I use. It's Space Claim Engineer. There are many different kinds of CAD softwares. You could do this in any one of them, but I like to kind of start here. And so I'm going to open up this step file that the customer has sent on his part, and we're going to check a few things and make a few little minor edits to this just to make sure we're good. First, we're going to check some diameters to make sure that they match what we want to do with the machining. See, everybody models their parts differently. Some model to the middle of the tolerance, some to the minor sides and the maximum sides. So you got to check this stuff on the model if the customer supplies you a model to make sure that you're in the right place. So this particular diameter of this part is the actual tolerance on the drawing is 5.115 to 5.113. So it's actually a plus or minus 1 tolerance, but it's at the maximum size. So we're going to go 5.114 divided by 2. This is the middle of the tolerance. I like to set that. And I'm going to just double check that I did that correctly. Okay, now it's at 5.114 diameter. This diameter is 6 inches on the print, and it's 6 inches on the model. And this diameter is 16, and it's 16 on the print. This diameter is 2.5 inches, so that all looks good. This chamfer, let's see if I can get this there, is 1/4 of an inch, and it's a 1/2 thousandth off, but that's good. This radius is 1/2 inch, that's good. This one's 0.442. The drawing says 0.44 plus or minus 10, so that's good. Now this diameter here, we're not doing this on the first operation, but it's at 10 inches, and the print's calling for 10 to 9.995. So let's also change that for the future. We're not going to do that in this operation, but we're going to say 9.9975 divided by 2. That's going to put that in the middle of the tolerance, if I did that right. Let me just double check it. Okay. Now, this dimension from here to here on this part is 4.5 inches on the print. That's good. So, well, let's check this one too for the next operation. That's 1/2 inch. That's good. So everything is pretty good dimensionally now for our machine work. This is kind of important to do. Not everybody models the same, like I said, and you have to check this stuff. I'm going to put some corner breaks on this part because I want this geometry when I get into the CAM software. So I'm going to put 10 thousandths on that corner, 10 thousandths on that one, and 10 thousandths on that one, just so we have some corner radius breaks for the turning work. Now we've got the model kind of edited the way we want, but as you see the world coordinate system here, if you see it right there, the XYZ is not in the right location for the machine. Now I could do this in the CAM software and reposition it, but it's just easier to do it here. At least for me it is. So I'm going to select the model, and I'm going to put my point of where I want to move from on the model there, which is that face, in the center of that face, and I want to move it to the world coordinate system right there. Okay, so that looks pretty good. I'm going to actually check that just to make sure I didn't screw up anywhere, and make sure everything is parallel and square. Kind of got to make sure of these things just to be sure. And I'm looking at the position of these holes, and that'll work fine. That isn't critical on this part because there's no other features in relation to those holes, so I'm not going to worry about that for the purpose of this. First operation is going to be all turning. I'm going to do those holes when I turn it around like this. So that position is still not quite right because you can see the z-axis is facing upward, and we want the z to face or go down the middle of this diameter of the part for the turning purposes. So we're going to go back here and we're going to move it again. We're going to set our axis of rotation at the world coordinate system, and we're going to move it minus 90 degrees. I could have done this in either the X or the Y, it wouldn't matter on this part because there's no features that are important for the first operation because it's all turning. If we had holes and stuff here and then holes that had to line up to these holes, we would have to worry about that, but we don't in this case. So now if I rotate this around, kind of reposition it here, we can see that this is right in relation to the machine now. See, the Z is running down the part, the X is going up, and the Y plus on the Mazak faces towards you in the front of the machine. So that's all good. Now we're going to double check that one more time just to make sure I didn't do something wrong. It's always good to double check. Now everything we want as far as the machining work is correct. Now we've got the diameters the way we want, we've got the part positioned, and everything should be good. So we can save this file, save as. And the only reason I did this once before. This isn't the first take of this video clip, so I'm going to save it over the one I did before. And the only reason I'm doing this is that I'm going to move it to my other computer because my CAM software isn't on this computer that has the CAD software. I kind of like to keep these separate because when I'm actually running the machine and making edits to my CAM file, I can look at and measure things in the CAD software easier this way, having them on two separate computers. That's not really necessary, but that's the way I do it. So now we're ready to go move this file to the CAM software, and I'm going to show you what I do there. Alright, I moved the USB stick over to the other computer. Here we are, and we're going to open up the spree here. This is a spree TNG. I have two different versions of a spree. This is the one that has the nice simulation. So I'm going to go to recent, and I'm going to open up a saved, kind of a template I have saved of the Mazak with the model and everything. And the first thing we're going to do is we're going to import the file that we saved from the other computer, which is that one there. Okay, I don't have to analyze the CAD, we know it's correct. So there is the model, and we can see it's positioned in the right location. So now we're going to go to the part setup, and we're going to select the model because we just imported it, and now we got to select it as our part. Right, so say OK to that. We're going to put a bar around that. It's coming out with the actual shape of the bar is 16 1/8 on the OD, no inside diameter, and it's 16.180. I think it's about 16 3/16 long, and we're going to line it to the top, but then we're going to move it out another 30 thousandths in front, so we have some material to face off the front of the part. And we're going to say OK to that. That's good. And OK again. And then we're going to go to the machine part of this. First we're going to, these jaws aren't quite the right jaws, but they'll suffice for what we're doing here. But I've got to rotate them 180 degrees. So they're facing the other direction. I'm going to 1.5. I'm going to move them out a little bit further so that I think that's out far enough to grip the stock. I can change that later if that's not the way it needs to be. And then we got to go back here again, and we're going to put a workpiece in here. That workpiece we already established. I'm going to move it out here so I can see where it is, because it sets it back at the 0 point back here of the machine, or the machine's model here in this particular setup. So I got to do that. And then I'm going to select this face and that face, and we're going to align those, and then we're going to say equals. We're going to set it another 3/4 of an inch minus 0.75. I think that's the step height of the jaws I'm actually using. Okay. I'm going to say okay. I'm going to have to do one more thing. I see I don't have the jaws out far enough here, so I'm going to say minus 2 inches. Oop. What did I say? 2 inches, not minus. Let's see if that's out far enough. Okay, yeah. Now I can close them on the part. Okay. So all that stuff is more or less necessary for the simulation purposes of this. If I reduce or increase the transparency, I guess, of the stock, you can see the model there. All right, so that's what we got to do to that part of it. Now I'm gonna save this to a particular location because I don't want to wherever it was now here. I got this kind of weird here, but that's the way I do it. And I'm going to call it what I call it, 830-01 OP-1 Operation 1. We'll just say that. Save. So I don't actually save it over my template file like that. Okay, now I'm going to move this from the default layer over to the part solid layer. I've already kind of got that established there. Then I'm going to make a new layer and call it geometry for turning here. What we want to do is have this there. See, the z-axis is now facing this way. For the turning profile, we need the turning profiles in the XY axis, if you will. It's not actually the XY axis, but it's with the z-axis facing outward like this for the purpose of making these profiles. Okay. Now we got to go over here to feature, and we're going to select turning profile. I'm going to select this solid model here. We don't want features, but we want geometry, and we're just going to do a full. I'm going to increase the resolution of these. I found this works better. And we're going to go OK. Now I can turn this model off because we don't actually need to see the model. And I'm going to make another layer called turning. I mean, all this isn't totally necessary. I just like to keep this neat so I can hide and show certain things. And it just makes it easier to deal with. Now we're going to actually make some features, and I do this manually usually. I mean, it'll do all this automatically, but I don't like the way it does it a lot of times. So first of all, I'm going to let's go backwards here. Let's create a little bit of geometry, just because I want this to create a facing feature. It would probably do this automatically, but I'm just going to do it the way I like to do it. That's all I need, really. Now it's just going to be my rough face. I'm going to name that up here rough face. And like I said, there's probably people watching this that use this Esprit a lot more, you know, and are better at it than I am. But this is the way I do it, and it works for me. Now I'm going to make another manual chain. This is going to be for my roughing profile, to rough all this stock off of here. See, I might have a little short segment in here. I don't like the way it made that blend arc. I'm gonna change. I'm gonna make that again. Okay, we're gonna end that right there. I don't like the way it made this arc here. I'm going to edit that, and we're going to call it, okay. Doesn't look, see how that looks different in the geometry? That's kind of weird. In fact, I'm gonna edit that geometry. For some reason in the CAD model or something transferred over funny. So we're going to take this. That's why I like to put these on different layers, because sometimes you need to select this stuff. That arc to that segment. Strange. See, it's showing me an arc there, but it's... Oh, wait, I know what it is. I got to see it on the right layer. I turned the layer off that I was using. I don't need that. All right. That, I'm going to move that back to the layer it should be on. Sorry about that. Let me see if I can see that now. Yeah. I should have changed my layer to that layer. I was drawing on a hidden layer. Right. Anyway, this is our chain for. I'm going to name that rough OD. And now I'm going to make a feature for the bore. And I'm only going to make that halfway down the part. There's a midpoint somewhere in here. Say, okay. Going to be bore. Because I'm going to have to bore this hole out. I don't have a drill the size, that 2.5 inch diameter that is. Do another feature that's going to be the finish face. It's going to go between there and there. Call that the finished face. And then we're going to do another chain that's going to come down here. It's going to be kind of a rough finish face coming down that face. Okay. Now you can make these as you go, kind of. Sometimes I do that, you know, instead of making them all first. I'm going to make another. I'll make another profile there. That's going to be our finish. I'm going to do these two diameters separate. That was 5.114 diameter. I'm going to select each one of them individually. There might be a gap here in the geometry. No, it doesn't look like it. I'm going to do an auto chain on that. See what that looks like. Okay. We're going to call this finish 6.0. just to keep track of things here so we know what we're dealing with. Okay. Those are all the turning features, I think. Yeah. That we need. Did the bore, yeah, the OD, everything's done there. Now we've got to change this back to the normal world coordinate system here, and we're going to turn the model back on, and we're going to select this hole there, and I want to go hole, and I want to go OK. Hide this. It's not going back to the face in the back, but that doesn't matter for what I want to do here because I'm working from this side. Now, that's kind of all I need to do here. Now what we're going to do is we're going to actually face this part, rough face it, and then we're going to drill this hole halfway up the part, or a little more than halfway up the part, and then we're going to unchuck the part and flip it around, and then we're going to drill the hole, do the same thing again. So we're going to select the rough face, we're going to go over here to turning, and we're going to roughing. You know something? I didn't do something. I need to bring the tools that I need in here, because this template doesn't have any tooling in it. So I'm going to save the file here, just in case something goes wrong here. And I'm going to select all these. See if I can drag those over there all at once. Okay. Sometimes that takes a little bit of time because all these tools have like models and everything for simulation. So now let's go back to turning, roughing, and you'll see that the tool is there. If I don't have the tools in the tooling tool assemblies, it doesn't select them automatically. 418 worked pretty good on the surface footage for my last parts with this material, so I'm going to leave that alone. 15,000 speed, that looks good. Low range, offset looks good. Strategy is going to be face. Start extension 100. We don't need any end extension on facing cycle. And automation, we're going to leave 5 thousandths and 0. 5,000 stock and, well, let me think about that. No, I'm going to leave more on this because it's going to be just the first face, and then we're going to flip the part around. Depth of cut, everything. Okay, that looks pretty good. Lengths, 9 inches. Yeah, that looks good. This is the clearance it's going to start at. It's okay. That looks pretty good there. Rough. We're going to rename that rough. First roughing of the face. Sometimes this thing does this on the, when it first draws this. I don't know. This might be like a little software quirk. If we go to simulation and simulate it, it does it all right. And then I think after that it doesn't show it that way. It's kind of weird. Well, see, it still does for some reason. I don't know. That I've noticed that with the software. Now we're going to do this. Let me see if I can select this hole and drill. Let's see if I got this tool set up in here already. I'm going to do it as a turning tool. So we're going to drilling. That looks good. It makes the part rotate like on a lathe, and the tool is clamped in the milling spindle this way. So surface footage is a little bit high. Let's I'm going to go 350. Let's look and see what that looks like. 649. We could try that. We'll go 0.003 maybe. That might be all right per revolution. Feed unit is per. That's good. This offset needs to be 3. On the Mazak, you can have many offsets on the same tool. So that's what the 4.03 means here. It's the ABC 0.03 offset and you have to make sure this is the same as that number, or you have to run into trouble. Well, you won't. You'll just have to edit it when you run the program the first time because you get the wrong tool. Total depth. Now here we want to. We're not using chamfer diameter. We're not considering the tip of the tool, and the total depth. The part's overall length is 15.5. So you want to go maybe 8 inches deep, a little further than the halfway through the part. And links, that looks good. Notice it has the everything clamped here. Okay, that looks good. Okay, we're going to call this drill. Then we're going to flip the part around, and we're going to actually do the same thing. So we're going to just restart the program. We might have to set the Z offset in a little bit. In fact, let's just, I'm going to put this at 5 thousandths. That's what I'm going to do when I actually run it. I'm not going to worry about putting this all in the program. I'm going to run the first two tools, just rough it. Let me slow this down on the simulation. We're going to rough the face. I'm going to cut this. And then we're going to drill that hole halfway up the part. Now, if this drill was a lot closer to the size I was dealing with, this is a 2 1/16 inch drill, and the hole finishes to 2.5 inches. I would skim something on the OD because I'd have to be worrying about run out if the drill was a lot closer to that finished bore size, but it's not. It's way smaller, so I'm not even going to skim the OD here. I've got the part running reasonably true, so I think I indicated it running true up here, but out here it's running out about 20 thousandths total indicated run out, but it's not enough to worry about, so I'm not going to worry about that. But I just wanted a clean face because where it's mating up against the jaws, the actual jaws that have a step right here, I had to knock it around a little bit because the saw cut's not perfectly square, and I want to take this out and flip it around, and I'm going to do exactly the same thing. So I'm going to just stop the program and restart it. So I'm not going to worry about putting that in the program. I'm just going to figure this is starting over again. So we're going to rough the OD. Well, we're going to actually, we've already faced it and drilled it, and we're going to do that again when we flip it around, and now we're going to rough the OD. So turning, roughing here, and in this case we're going to leave about 10 thousandths in X on the roughing cycle. Let's check all this. This is all good. Offset's good. We're going to change this to OD. And all of that looks good. That'll work for what we're doing. Finish pass. 1/4 inch depth of cut. That's good. Everything looks good. So we'll just say okay. I think I may want to extend this path. You see how close it comes to the jaws on the simulation here. I may not be able to go back that far. I'm going to see here. Let me speed this up just a hair. Might be able to go further back. Depends on what's actually there. I actually run this. I'd like to go a little bit beyond the end of that flange if I can, so I can run the finishing tool right up to the end and finish the whole OD of the part. That way when I flip it around I can indicate on that OD. In fact, let me I'm going to extend this. I'm going to have to watch this closely when I run it on the machine because sometimes things aren't perfect, but I'm going to extend this end 100 thousandths. And that should still clear the jaws according to what I saw before. I think the step, I set the part back 3/4 of an inch for the step and the jaws, but I think it's just slightly less than that, I think. And I measured the length of the stock and it was pretty close, so we're going to say that's okay for roughing the OD down. Actually, before that, we already got the hole drilled halfway, and it should meet the other hole that we drilled from the other side when we flipped the part around. Rough the OD, rough and finish the, rough the face, rough the OD. Okay, now we're going to finish the face down here. Let's go contouring. We're going to call it the face again. All this is right. The tool's right. That's correct. Feed and speed is good. I like that. This is just comes. This software saves your settings from previously set. So I'm going to extend the length, and I'm going to extend the end a little bit. 0.25. I'm going to go down. I want to face all the way down into this hole here. I think that. No, I got a 1/4 inch chamfer. I'm going to extend it 1/2 inch. Let me see if that got down far enough. Yeah, it's going to go a little beyond that hole. I'm going to rename that finished face. Okay, I don't need that lead-in arc. I don't need a radius on that lead-in. That was, I could see that right here, see it? In fact, I'm going to extend that beginning of that just a little bit more, just to be sure I don't hit any metal. Now I'm going to rough finish this. Actually, I can just copy and paste that, but I'm going to change this a little bit. Down here at the bottom mostly, I want to not have a end extension, and I'm going to, have a radius coming out from that, something like that. Let's see, like that. I'm going to add a little stock to that. Where is the stock here? 0.002 thousandths. And that just roughs the majority of the stock off the face coming downward. Now we're going to put the 2 finish cuts on the, finish this. There's a contouring again. Strategy of the OD. Tool is the correct tool. I think our feeds and speeds are all the same. That's fine. Wait a minute, maybe yeah, that's fine, that'll work. I might check this on the, no, it's going to be fine. On the roughing cycle, I don't want to turn any 1000 RPM. This is set for a maximum of 1000 RPM in high range, but I think the turning cycle is in low range, and it can only go to 460 RPM in low range anyway, so it's probably not a problem. Start extension, back that off to there, and I'm going to go 50 thousandths on the end extension. No, 100 on that. And I don't need a radius on the end of this. Oop. Just a lead out, normal lead out. I could leave that the same. Okay. Rename that to finish 5.114 diameter. I just name these things. I mean, you could do all this and never name anything, but it's easier if you got to go back and find something. And I could actually copy and paste that 6.0 diameter. And what I want to do on this one on the strategy is only go about 50 thousandths beyond, so don't hit the shoulder of my roughing tool left, and no extension on the front because I got this blend arc. I don't want to gouge that big radius. And my contour, I'm going to put a blend, kind of a where is it, this thing, kind of a blend into that radius so it makes it kind of nicer. I could leave that okay. It's going to wrap it back and forth a little bit. Oop, see, I don't want, that's going to gouge my radius. I thought I changed this. Oh, put them backwards. Okay, that's better. See how that looks? Okay, and the end should be stopping short of my roughing tool. Okay, and then if all that works out and I'm not hitting my chuck jaws, that should be fine. I'm not sure I have the boring bar in here. Let's see. Silent bar. Oh, I do. Okay. See, that should look like that, but I want to set that at 0. No, at 90 degrees. Excuse me. 90. I don't believe you. Sorry. Okay. I'm going to shift this to high range because I'm not going to get the RPM I need, because this is 2.5 diameter. If I want to run at that, I can't. I have to be in high range. Okay. I'm going to slow this feed down just a hair. I'm going to be ID, start extension, end extension. I'm going to go 0.2, just so I'm beyond center a little bit. I think I'm going to do the finish path separate, so I can put a little blend on the exit of the profile. Actually, I think I'm going to take this at, if it doesn't hit my boring bar up here on this shoulder, I'm going to go 300 with the roughing cycle. And I'm going to go 100 thousandths depth of cut. That should be all right. These links, I'm going to have to change this to 0.95, I think. Oh, I'm going to go more than that. I'm going to go 1 inch. I should be able to clear it because it was a 2 1/16 inch drill, right? So that'd be 2 inches. And I think I'm liking that. Okay, let me turn off this part solid so I can see what I'm doing here. I'm going to rename this. It might think it's hitting the end of the hole here, but we know I've drilled that hole from both sides all the way through. And we're going to see in a second here what it does. And then we're going to select the same profile. I'm going to put a contouring, we got to select it here. Contouring. I'm going to select the same tool. It's our Sandvik silent bar. I've got to go back and change this to the other cycle. That has to match our offset. 5 thousandths. I'm going to go 750 surface footage. We're going to see how that works. 5 thousandths feed. ID. And that doesn't matter for this purpose. I'm going to go 0, 0. I've got to check those on the other finish passes. I may have not changed them. And this beginning, and this we want to put an arc here. Something like that. Strategy. 0.1, I'm going to 0.1. Let's see how that looks. Got to have it tab. Okay. What is it doing there? See, that's not good. Got to check this. I see these dotted lines going through the part because I didn't change these to 1 inch. Right? That's better. All right. It might show a collision on the bottom of this hole because I didn't actually, I might not be drilling that far enough for what I'm boring it, but you know I'm drilling it from both ends because I'm turning the part around. So it'll be all right, but it might show a collision right down here. Let's see what this looks like other than that. I'm pretty sure it's going to do that. Okay, this is the Sandvik 45-degree roughing tool. I do this here because I'm going to hit my chuck jaws if I use the normal roughing tool. But the finishing tool will clear the chuck jaws at the 6-inch diameter because I have it sticking out a little bit further than my straight out roughing tool, if you will. This is the 45 tool won't hit because it's tipped at 45. Okay, so see this tool, well, it sticks out just a little further so I can clear that. Okay, so those are my rough turning. I got to go back and check a few things on that as far as my finish amounts. So I think I didn't leave enough finish stuff. Well, no, it didn't hit. Okay. I thought it would hit back here. It looks like it. The hole ends right there. Okay, so that's the whole program actually for this side of the part. I'm going to do a few. Like I said, I'm going to check, make sure my that rough finish face doesn't matter. I think I put that all right, but I think I didn't put the, yeah, see, I don't have the, I want to leave those at 0. And I think my rough boring cycle needs to be set here for the 5.09. This has to be set on a 9. Okay. So that should be everything. I want to put some a park cycle between these two turning cycles. Everything is set okay on that park cycle. I want to put it between here. So I want the machine to definitely stop right there with a park and this makes it recall the offset and everything, so when it's coming down I can change the offset between these two turning cycles. I might put another one between the facing cycles, just so it stops, and then I can have a chance to adjust something or do something if I need to. I'm not worried, we're not running but 2 parts here, and it doesn't matter. Can't remember. 7015 I think is my next, and we're going to call this, and that's what we're going to save there. I think we should be all right for process code. If there's any errors in the cycle, like, this thing will detect it and will tell you before it'll even process the code. Like if you have some kind of a, well, let me show you. Well, where is this going to? Spree files. I'm going to save this over to my stick. So that I have to bring it to the other computer to send it to the machine. But this is Spree. TNG has unusual things because it has these links between processes and everything. So it actually checks the rapid moves and everything. If there's any collision or anything like that, or whatever, it'll detect it in these links. And even if you're going out of machine limits or anything, and it'll detect that, and it'll tell you if you try to process code and you have an error. So that's the programming part of it. Now we got to get over to the machine and actually run this thing.